Good afternoon, everyone. Almost to the finish line here in the afternoon. My name is Jimmy Bogard. You can find me on X, formerly known as Twitter, while it's still alive and running, I guess, at @jbogard. And this presentation can be found on my GitHub at github.com/jbogard. And I blog about these kinds of topics on my blog at jimmybogard.com. My day job is as a consultant, and I mainly focus on system application modernization. And this talk in particular is from a recent project in which we were migrating a client from their on-premise system up to the cloud in Azure. And so this is something I've done a number of times in the past. And what I've inevitably found is that every single one of these kinds of projects is always unique in some specific way. So I'll be talking a lot about the things that I ran into in my project doing these kind of things. They won't be the same things that you run into in your Azure migration, but that's okay. Hopefully I can leave you with some tools and techniques to help make that migration easier. But I'm definitely going to hit resources that you don't hit, and you're going to hit resources that I don't hit, and that is okay. So kind of reminded of the book Anna Karenina from Tolstoy, and the opening line is just this kind of classic line of happy families are all alike. Every unhappy family is unhappy in its own way. Similarly, cloud migrations are the same, where if you're starting from a completely blank slate, you can make all sorts of choices and kind of pick whatever resource you want, and you get to do whatever you kind of whatever you want in that system. But when I'm dealing with on-prem existing systems, then they're going to have their own unique challenges and complications, and so they're always going to be different and never going to be exactly the same. Now, this system in particular was being in use in production at that time and being actively developed and maintained. And so what we couldn't do is just say, let's just pause all developments and all feature work for 3 months or whatever while we figure out how we're going to do the migration, plan the migration, and then roll it out. Instead, it's more like how they build highways in Texas, which is in these incremental phases. And in this kind of process, we never... it's not like we build a completely new highway to the side and then get it all nice and shiny and up and running. And then one day there's just this big traffic switch and everyone goes over to the new highway. I say that, but we actually did that once in Texas. But usually what goes on is they're upgrading the highway as they go. And during those transition periods where there's old highway and new highway, it's going to be bumpy, right? You're going to have these awkward transitions. It'll be temporary roads and it'll just kind of be a little bit bumpy as we go. But the idea is that we can't just shut down the entire highway and then create something off to the side. Similarly, I can't necessarily just shut down all new feature work and new development and say, just pause for a bit while we figure things out and then go migrate over to the cloud. Instead, it's going to be a very sort of incremental process. So in any kind of projects like this, it usually starts out with some kind of discovery assessment phase. And so what we're trying to do here is just understand the lay of the land. What are the kinds of things that they have on premise, and what are the things we want to move to in the cloud. This also will be looking at what things do we want to move, and what things do we not want to move? So this customer and most of mine don't really migrate everything all at once. They're not trying to migrate every single virtual machine up to the cloud. It's really okay, let's go do this in phases where there's these set of applications that have a kind of a high win, high upside, and say we'll move those first. Learn our lessons from doing that migration, and then over time migrate the rest of their systems. Now, I know there are tools from Microsoft to do this big bang migration, but what we found typically is that those kinds of tools will just be more of a lift and shift. So they'll take exactly what you've got on premise and just do the same thing in the cloud. And so for some customers, that's an okay transition, but this organization also wanted to modernize. So they wanted to make something better in the cloud than what they had before. They didn't want to just take their exact existing VMs they were running on premise and just say, go ahead and just dump them up in the cloud. That wouldn't get them to a better spot. So along with this, we also wanted to kind of make things better and land in a better spot than we were. Microsoft also has some tooling here to help you do this. They have some new capabilities in Azure Migrate. At the time we did this project, This was like a couple years ago. The better Azure migrate tools did not exist. So I'd say if you're at the start of this journey, definitely go look at those tools from Azure and Azure Migrate. At the time, though, the Azure Migrate tools was like point us at your virtualized infrastructure, and we'll tell you exactly what VMs we can create in the cloud for those. Like, well, that's not what we want. We don't want to just lift and shift VMs. We want to, as much as possible, move to the better thing in the cloud. So in this phase, we were looking at what are the compute resources that we have? So this is the server infrastructure. Things like what applications are running out there, how are they running, how are they being hosted, what information is being written to, where's that information being written to? So like, what databases do you have if you're using file storage, because everyone uses file storage still, especially on-prem. What are you doing there? And if they have any other kind of like message queuing or logs, or anything like that, go and gather all of those resources as well. And we also want to understand what are the different environments that they support. So, do they have a dev environment and a production environment? They have 4 kind of pre-production environments, 2 pre-productions. What are the different environments that we need to support? Because we want to also do that up in the cloud as well. We were also looking at their network infrastructure. I am not a network person. We had a good network person on my team. So if you have questions about this, I will either make something up or I'll just point you to some resource online because I don't know. There's lots of acronyms that were being thrown about during this time. And I knew like everything had to be set up just right or nothing would work. But we had a good team of folks on the infrastructure operations side that understood all these things and could get it set up for us appropriately. We also wanted to just understand, because we weren't going to be stopping the train of feature development, I wanted to also understand how the team does their software development. Because if we're going to be in this like transitional phase where there may be environments both on-prem and in the cloud, we wanted to make sure that if that affects their software development lifecycle, that we kind of get ahead of that and we don't surprise them like, oops, you can't test that feature for another month because the environment doesn't exist or something like that. So we want to understand just kind of like, what are the processes they use, and how will we then incorporate our work into that process. All right, so in this particular application, in terms of like the systems they actually had running, it wasn't a huge site. This one was a website that was for college applications and scholarships. So it's for scholarship grants to students here. So it didn't have a ton of users, but it was very important to those users because it was also the system that the students would use to like, I need money for something, and they would use this system to get the money. And if that system didn't work, they wouldn't get the money. So it was very important to those group of users. So this system had two web applications. There was an internal like admin application, and then an external facing public application as well. And of course, it had different security sort of postures for each of those applications as well. This application was on ASP.NET 4.8, but at the same time, they were also migrating to .NET 6. This talk is not about the .NET migration. I actually have a whole different talk that's about .NET migration. There were a couple things though that we had to worry about in this like transition from on-prem up to Azure, because there were some things that .NET ASP.NET Core supported differently in Azure than on-prem, which was awesome to find out when we tried to deploy something and it didn't work because when we deployed Azure, they're like, no, you can't use that here. It also had various middleware like Hangfire for background tasks, SignalR for real-time notifications to the browser. Didn't have any like messaging endpoints, so there wasn't any like MSMQ or RabbitMQ going on. Luckily, that would have been a bit more challenging to migrate that to the cloud, but we do have some techniques to be able to do that as well. There were 2 application databases, and the internal, based on us evaluating the different applications, the internal one communicated to both applications, and the external application had its own like public database just for that single application. And it still used SQL Server Agent to for some like scheduled tasks and scheduled jobs. Now, the tool that you can use these days to make this kind of analysis easier is the Azure Migrate tool. You can point it as like a Visual Studio plugin. You can point it to your solution, and it will analyze the code. It will see how you're using the code, and it will tell you which things you may need to change when you move up to the cloud. It won't catch everything, but it does a pretty good job of saying like, okay, this is how you're doing things this way here. You'll need to provide a shim or provide a different way of doing it whenever you move up to the cloud based on here are the resources that you're trying to target once you're up there. So on the software development lifecycle side, they had 3 deploy environments. They had a QA environment, which is their kind of like pull, they had a pull request to review. They push it up to the QA environment. They had a pre-production, like final gate in the stage, and production with stage gating production. So you had to deploy to stage and then would promote from stage to production. And this was important for us to understand because if, again, we're in this transition period where we have some environments in some places, I wanted to understand, like, if we're going to disrupt this process, how can we make sure we still support those engineers during that time period? We also had various integrations with other stuff. So we had both incoming webhooks to our application. So things like, oh gosh, so they're using Twilio and SendGrid, and they wanted to get notified if one of those failed, if actually both, if it succeeded or failed, because they had internal, internal tables and stuff to say, okay, I need to notify the student that their check is ready or something, and so we'll send them an email. But if SendGrid is down, then they'll need to manage that downtime. So there was also like database stuff behind the scenes to keep track of this, and then webhooks to say, okay, this succeeded or failed. And we also had like incoming API calls as well as outgoing API calls from all this, with all sorts of different security measures in place to lock down these different APIs based on whatever that API provider was, and then also like what our security posture was as well. So this is production for them. Again, not a huge number of users, but it was still in a web farm scenario with a load balancer. So we had a load balancer on the front, and then that would then load balance between 2 application servers, 2 web application servers, each both having the applications on that hosted with IIS. And then those talked to databases behind the scenes, and they also had a production file server. Now, one of the things we found here, which was a good thing, is that because they were already in a web farm environment, they couldn't do a lot of really bad things that people do when they know they're just on one single server. We had another client moving to cloud where they just had a single server hosting their application, and they did all sorts of dirty tricks like using static variables to cache things, and then went to a web farm to that thing didn't exist and would throw all sorts of exceptions sometimes, because we didn't have session affinity turned on or whatever. So because they were already in a web farm environment, they couldn't do any of those those sort of hacks to make things work that you can do on a single server. So luckily this was actually a bit easier because we knew we were going to be targeting a load balance scenario up in Azure as well. On the QA stage server, so they're lower environments, they were intended to be like production instances. That's something I know a lot of customers try to do. It's like try to make lower environments as much as possible look like production until they get the bill for those things. They're like, maybe not. Maybe let's smooth things down a bit. So in this case, they actually had both QA and stage on the same system, but these the sort of like the hardware and CPU were the same as production. Okay, so networking side. I know there was like some stuff that would then talk to some more stuff, that then would talk to even more stuff, and then finally go to our junk. The network engineers would explain it to me many times about exactly. I was like, okay, fine, you know what? Just tell it to that guy who is the infrastructure Azure person, and then let me know when it's working so that I can actually then go make sure that our junk actually works. So there was a lot here behind the scenes. They had several custom DNS resolvers internally with 2 different VPNs they had to support. And based on which VPN you are, you can only get access to certain resources. So we had to do a lot of stuff to make sure that that still worked once we got into Azure. But I didn't do any of it, so we won't be talking about it. So there. And then finally, looking at their software development lifecycle, this was another one of those things of okay, if they're modernizing their applications, should they also modernize their application lifecycle stuff? So in this case, all their SDLC stuff, because their systems were on-prem, even all their SDLC stuff was also on-prem. So they were using on-prem Bitbucket, on-prem Jira. For build, they're using Pasaki PowerShell, whatever. And then for their build and deploy, they had TeamCity doing both, on-prem TeamCity calling something called calling Pasaki, and the CD was calling something called Pastrami. I forgot this tool even existed. It's a PowerShell-like continuous deployment tool. It's actually on NuGet, but the last deployment of that thing was 10 years ago. So that was when we looked at, maybe we should not use that thing anymore, and like, what is the right sort of CD tool for Azure? Yeah, so it looks something like this, Bitbucket, TeamCity, and TeamCity. All right, so once we kind of gathered the lay of the land of all these different aspects, the next thing we want to do was the design phase. So what should they be moving to? The team did tell us that they don't want to just do a pure lift and shift, but they don't want to go too crazy with like a bunch of new kinds of resources. So as much as possible, what we try to do is apply some sort of guiding principles to choosing the appropriate resources up in Azure. So first principle is like, we want to do platform as a service. So using, like, they didn't care about sort of vendor lock-in, whatever, so they weren't like, well, maybe next year we'll go to Amazon, and maybe the year after that we'll go to Google Cloud. They're like, no, it takes so much work to get all this set up that it'd be like astronomically expensive to try to support multi-cloud. They didn't care about that sort of thing. So as much as possible, we wanted to leverage the features of that platform, because that's what they, that's one of the things they want to do is, modernize, make things better, not make things the same as they were today. We would use infrastructure as a service if we were forced to. So if there was some reason that we could not use the platform as a service play, then we would then drop down to infrastructure as a service. In the end, we only had to use like bare metal VMs for very few sorts of resources, and most of them were temporary, or things like jump boxes, a machine you can remote into that's inside that network boundary that can access and then be able to get to all the resources. But otherwise, the actual applications themselves were able to go to platform as a service. We wanted to avoid like any kind of like, oh, while we're here, why don't we make this better? Or like, no, like laser focus that the goal here is to do the Azure migration, not try to add a bunch of other things as we go. So this is kind of a like pacified lift and shift, where we take the existing resources they have today and then put them in the appropriate platform as a service play up in the cloud. There were still some things that we didn't know weren't going to work until we got inside of Azure, but I'll cover those as we get to them. On the SDLC tooling, so we looked and saw that, okay, you're using all these other on-prem things. Is now the appropriate time to get off of those into something else? So Jira, like, I wanted so desperately to get off of this, but the problem was that their whole organization used Jira, not just this team, but all the other teams as well. And so this would have been a much bigger scope item to say, let's move you also from Jira on-prem, even to look like Atlassian Cloud. Because everyone used it, and they had like global templates of work items and whatever. This was not going to be possible, so we just kept them on-prem Jira. Bitbucket, though, is a bit easier, though, because it's Git, right? So you have your own individual repository. The most you have to really worry about is like different security rules and things like that. So they did want to get off of Bitbucket onto something else, and the team then decided to go to GitHub. So they got a GitHub enterprise account thing, and we were going to be moving them over to GitHub. The Saki tool, it's just PowerShell. So we're like, the team likes PowerShell. They're comfortable with it. I don't really like it. I feel like every time I touch PowerShell, I have to relearn everything about it. They liked it, whatever. So we kept that as well. Finally, for the build and deploy, so we had TeamCity. So technically, we could have still used TeamCity to deploy up into Azure, but again, they were trying to get rid of all these kinds of services they were having to maintain over time, manage the updates of these sort of things as well. So for this, they decided to go to Azure DevOps for build and deploy. Now, I don't know why they decided to go GitHub for source control and then Azure DevOps for the other stuff versus just like picking one or the other. Whatever, they like GitHub for pull requests and they like Azure DevOps for all the stuff that it does. Azure DevOps pipelines, I should say. All right, so on the Azure resource side, we wanted to look to see, okay, what is going to be the appropriate sort of Azure resources for the compute and storage up in the cloud. Now this is again one that if you use the Azure Migrate tooling, it will tell you like, here's the Azure VM that you can size for this, but that wasn't important to us. So we looked at what are the existing resources of your on-prem virtual machines, and then picking sort of the appropriate sizing for those resources up in Azure. But like, it's much easier for us to change those in Azure. You got the magic slider that says, go more cores or less cores or whatever. So we just made a good first guess of this. And then later on, we could look at things like auto scaling for those peaks and valleys of the system based on their usage. So for the compute resources, so right now on-prem, they're using IaaS. And the equivalent to IaaS in Azure is Azure App Services. I mean, I think it actually is IaaS in the cloud, I think. So we knew that was going to be a very straightforward migration path to us. Yes, there are a bunch of extra features that we will be eventually taking advantage of with App Services. But this is like the most easiest way of like saying, I've got a web app running here. Now I'm going to take that web app and run it over there. For storage, okay, this is like the SQL Server agent stuff. SQL Server agents is one of those things you kind of forget exists because it doesn't really exist up in Azure unless you're using like the more infrastructure as a service options. So we saw this and said, okay, we want to use the more pacified version of Azure SQL up in the cloud, which is the Azure SQL databases, which does not support SQL Server agents. So we said, you know what, we don't like those anyway. It's running an executable inside SQL Server. It's just a weird thing. So we said, we don't want to use this anyway. We want to get off of this way of running background scheduled tasks. So we migrated those over to Hangfire. We did this before we did any kind of Azure migration whatsoever. So for these sort of like fix the thing before we get up to the cloud, we wanted to make sure that we fully vetted and deployed those on-prem before we mixed Azure into the mix, before we got Azure into the mix. So, database side. This is one of those ones, there's not really an either or option. There's a spectrum of things to choose from inside of Azure for SQL. There's on the more PaaS side is Azure SQL Database. So this is like, you have a database that's running on a virtual server, but you can then size that individual database's resources independent of other databases, even having like different kind of core models and different kind of charging models based on that. So that would be like kind of our ideal scenario is Azure SQL Database. In the middle is Azure SQL Managed Instance. So this is a pacified version of Azure SQL Server, not just the individual databases up in the cloud. So it's kind of this middle ground between like pure VMs over here on the right, and then like I just have a pacified Azure SQL database running somewhere, somehow, up in the cloud. Now, in order for us to figure out which one of these options is best for us, we also need to understand like what are the different capabilities that each of these support for the different features that we're running, as well as for the migration up into the cloud. These different versions of Azure SQL have different options for doing this migration up into Azure. So, and unfortunately, there are a ton of options here for doing this actual Azure SQL migration. Yes, so the first one is Azure Migrate. This is the assessment tool, but will also perform a migration. There is the Azure SQL Migration extension for Azure Data Studio, and this uses a data migration service to assess and perform the migration, and the migration is somewhere up in Azure as well. There's transactional replication, and this is one I wanted to avoid like the plague because it is very hard to set up. It's annoying to set up. There's a lot of security things. It's like up there with distributed transaction coordinator of like the most annoying things to set up and get right. And so the transactional replication would give us like the most liveness for updates. So I make a change here and it will show up very quickly up in the cloud. But we knew it was going to be really annoying to set up. And remember the clouds of networking stuff? Like mixing transactional replication on top of all that would have just been like a nightmare. So he said, only if absolutely necessary will we do this. We have Backpack. Backpack is like you can export the database as a special like zip file with manifest and the data inside of it. And so if you are able to basically stop people from using the application, you can export the database into a backpack file and then go in Azure and then import that backpack file up into your database. Behind the scenes, it actually uses the next tool here called SQL bulk copy. But this is a good choice if I have like a read-only database or a very slowly changing database, then Backpack is the easiest way to do the migration. I just export the data and then import the data, and then hopefully that finishes quickly. Then we have Azure Data Factory. Azure Data Factory is like SQL Server Integration Services, but in the cloud. So if you have to do ETL as part of your process, so there's like things you need to change in your data as it goes from on-prem up into the cloud, then Azure Data Factory is a good choice for that. For our system though, we didn't want to change data or change the shape of the data or anything really, just like make it look exactly like it does on-prem, but just over there now. And the final tool here is SQL Data Sync. SQL Data Sync is it's a tool. I'll actually talk more about this one, but it does client and server bidirectional syncing for Azure SQL to Azure SQL and Azure SQL to and from SQL Server on-prem. Now, in order to understand which one of these is most appropriate for us to use, we also have to understand like which of the Azure SQL database SKUs that each one of these tools can be used with, as well as do each of these tools support offline or online migration. So the offline migration means you stop everyone from using the server, you close all the connections, you use this ETL tool or whatever the tool is to then migrate your data to cloud, and then you can bring up the application pointing to the new database. Whereas an online migration means that it's ongoing and it's more of like a DNS swap to swap someone, or maybe like connection string swap to swap an application from the on-prem database to another database. And of course, depending on the tool, they support each of these kinds of scenarios. So we knew this application was still being used on an ongoing basis, and to keep our options open in terms of application downtime, we wanted to favor as much as possible the online migration options. Because if it was going to take a long time for whatever reason for us to migrate the application from one to the other, we didn't want to have a large amount of application downtime. So we wanted to go with the online models as much as possible. The other thing that made things worse for us is the on-prem servers were in Austin, Texas. The target environment was South Africa, and that's a long way away from Texas. The reason being is that this application was scholarships for students in South Africa, so we're like, hey, you're at Azure now. You can pick the region that best supports your users' needs, so why not put the application and data much closer to the people that are actually using the system versus like the administrators of the system who are in Texas. So those are one of the reasons why we were looking at using online migration tools, because we tested and timed a few of the offline migration options, and like going over the network over the entire Atlantic Ocean or Pacific, I don't even know which way the data went from where it was. It took like just absolutely forever, and we didn't want to take the application down for like a day waiting for this data to get pushed up from Texas over to South Africa. So an online migration lets us do a bulk insert of the initial data, and then ongoing migrations are much smaller because it's only then the deltas as we go. So in terms of tooling, we actually wound up going with the last option, SQL Data Sync. Now, the Azure migration documentation says don't use this for this purpose, but it worked really well, and so you're like, if it works, why not? And the reason why they don't want you to use it for this purpose is because they want you to use their other like purpose-built tools. They want you to use Azure Migration, Azure Migrate, or Azure Data Factory, which you have to pay for those. But you don't have to pay for SQL Data Sync, so we're like, let's use that one. So the way it works is it supports different synchronization models. There's an idea of a hub database and then a member database. And the hub database is like your destination for the data. And then the member databases are then other like participating databases that will get copied up into the hub database. There's also a separate sync database that holds the metadata about your synchronization. So like which of the databases that are being supported, what tables and which columns do you care about? Those are all stored in the separate database in the sync DB. Allegedly, you can also do sync between 3 or more databases. We didn't do this. It's really just like, okay, we have our target hub database up in Azure, so that's our eventual target, and then we also have our on-prem database, which is the other member database, and there's also going to be this sync agent. So this is a Windows service that runs on-prem somewhere that can connect to your on-prem database, look and see what the changes are, and then push those changes up into Azure. So there's something that has to run locally, of course. So your SQL database itself doesn't know that this is happening. We have a background sync agent that is pushing those changes up on some kind of scheduled basis. There are limitations to this, and there is a tool for Microsoft to run against your database to tell you, here are the problems that you're going to run into if you try to do this. And so things like, if I'm doing deltas, I need to understand what are the items that have changed. And the way we know which things have changed is that we look at the rows and look at the primary keys to know oh, this thing was added because this thing with this primary key doesn't exist over there. So every table must have a primary key, every single table that you're going to participate in this migration. Snapshot isolation must be enabled. I don't know why. I guess it's what the tool uses to perform this sort of work, is use snapshot isolation. This is just something we found in production. Lower environments had it turned on. Upper environments did not. So we had to go fiddle the SQL Server configuration to turn this on. The primary keys can't be weird. And by weird, I mean XML. You can have XML as a primary key, but I don't know why you do it, but you can't do that. Things like images, you can't have an image as your primary key. These are things that you would probably never ever see, but they can't be weird, I'd say. Your schema table call names also can't be weird. Things like don't use emoji in the names of your database. You can, actually. Your table schema, your database column, schemas, all that stuff can have emoji or weird, UTF characters, but they can't be weird. So just if they're vanilla normal, you're good. Table names must be unique. This is one that actually did bite us because the table names in a regular system don't have to be unique across schemas. But for whatever reason, this tool can't support unique table names that are not unique across schemas. I don't know why. So there were a couple tables like TBL address that was in 2 schemas. So we had to go change the name of it in one place to make sure it was unique everywhere. User-defined types aren't supported. So the thing that we all thought was really cool to do in 2008, probably shouldn't do that today anyway, but user-defined types aren't supported. Things like if you bypass the transactions and triggers, then they won't sync. So if you truncate a table, then the mechanism that the SQL Server data agent uses, which is just triggers, won't be fired, and so that won't work. But I'm not in the habit of randomly truncating tables in production, so this was not going to be a big problem for us. And like any kind of replication model, schema changes are not automatically replicated. So if I add or remove tables, add or remove columns, rename columns, whatever, this tool won't know about them. So we had to define a process to be able to take care of this sort of scenario. There is, again, some tooling from Microsoft that will help do this for you, but it sucks, so I wouldn't recommend using it. So we wound up just leveraging some of our existing schema change tooling into this schema change process. There are also some unsupported data types as part of this. And again, this is not something that we ran into, but if you look at some older databases, again, from the early mid-2000s, where Microsoft was pushing all this crazy stuff inside your database, then this may exist for you. Things like file stream. I don't even know what that would mean to replicate a file stream from on-prem up into the cloud. No user-defined types or CLR types. Again, I'm sorry if you have those in your system. You're probably annoyed by them today anyway. XML, I don't know. All sorts of weird things. But the really challenging one, though, that this system and most systems I see in production today was computed columns. So computed columns aren't actually stored anywhere, and so those won't be replicated. How could they be? So whatever. Or read-only columns. If you can't change the data, then there's no way to push those changes up to the cloud. For those last two, or for any of these really, you just kind of decide, do I change the existing system in order to get rid of these types? Or do I just migrate that data in some different way, like maybe just build a custom tool to be able to do so? Or if it's pervasive enough in your system, then you'd want to then just go to one of the other tools to do so. So going to and use like Azure Data Factory or Azure Migrate, which are much more complicated and more difficult to set up than this tool. This one also bit us as well, that there are limitations on the dimensions of your items as well. Like the max number, the one that really hit us was the naming here. The database table schema and column names cannot have more than 50 characters, which again is like, can't you just change the, the reason why this comes in is the sync database that holds all this metadata limited all the columns to 50. I'm like, varchar max is a thing, like you can do this. They didn't, whatever. Tables in a sync group, 500. Luckily, our database did not have over 500 tables, but I'm sure some of you today have like well into the 4 digits, maybe 5 digits, hopefully not, of number of tables. And so you just break this up into smaller groups, which you probably want to do anyway, because this can get resource intensive. These last two we also hit as well. So columns in a table in a sync group. You can't have more than 1,000 columns. You don't have more than 1,000 columns in a table in the production system. Like TBL user or person or whatever, it has like, just keep adding on those columns, go, go, go. So again, we didn't get bit by this. We did get bit though by the data row size. And this is actually hard to like figure out from your database. It's limited to 24 megabytes of a row. And so we did hit this in our production. And it wasn't like they were storing images. They were storing their log entries in TBL log, and that log entry was varchar max, and sometimes it would be like an insanely long stack trace that they would put in there and store it in their log table, and we're like, we don't want to keep the log table in Azure, right? We'll just use Azure Monitor like a normal person. So this one we just said, we're not going to migrate your log because who cares? If you need the logs for your historical system, you can still go back to the historical database, whatever. All right, so in terms of the migration process of changing schema, so we have like our, oh yes. So in terms of managing this migration, so the first thing we did was correct any schema issues based on running the tool to say like, okay, these tables don't have primary keys, these table names are too long, these column names are too long, this column name is weird, so fix it. So the very first thing is we would correct all the schema in their on-prem database first. The next thing we would do is then initialize the schema. So create a blank database up in Azure, and then export the schema from on-prem, and then import the schema, and then like create the tables, just everything blank up inside of Azure. And then finally, magic of syncing the data. So initializing is pretty straightforward, right? You can just right-click the thing, go to tasks, and just say generate a script that is all this stuff. So some of the things we would do is skip some of the auto-generated tables. So things like your EF migration tables or Hangfire, things that get created for you on the fly or automatically. We wind up skipping those because sometimes the application would not know that those are there and then create them for us. We also wanted to make sure we included all the other kind of related things like indexes and triggers and whatnot. The next thing we do inside of Azure is create a data sync group. And so what this is just saying here are the group of servers that I want to migrate, or the group of databases. And I do this, I'll show you here in a second. Inside the Azure portal, you go ahead and create this sync group. You can also turn on automatic syncing, but it's just on a scheduled basis. So for us, we just turn it off for now, and then as we get closer to production, we would turn on automatic syncing and make it run like every 10 minutes or 1 minute or whatever to ensure that the deltas when we went live were much lower. So this will just reduce the amount of time for that final sync before we turned on production. Then we also have to install a local sync agent. So you get to the point where you say, I want to create here's the database I want to sync, and I want to sync to this other database, and this other database is on-prem. At this point, you install a sync agent somewhere on your on-premise environment that can talk to both the Azure SQL database and to your on-prem database. So this one we would we just found a VM that was available for us and installed the SQL data agent on here. You can't install it on your SQL server. I typically don't because it is using resources. And we just needed to make sure it had enough resources to be able to the initial push up of data does by bulk copy. All right, so once I've created that seek agent and installed the sync agent locally, then I can select it up here in Azure. And then now on my on-prem VM, the local seek agent, I can then point it at the local database and point it up at the Azure database as well. So when I'm selecting the database up in Azure to say I want to synchronize this database, we also tell the directions I want to sync. And then it also supports bidirectional. So it supports from your hub database to your member database, from your member database to your hub database, or vice versa. And this is configurable and changeable. So for us, because we were wanting to potentially support a rollback operation, so if something went wrong in Azure and we needed to roll back to on-prem, we actually made it bidirectional so that during this transition period, if we put it live and something went wrong, how do we make sure the data from Azure makes it back down to on-prem? So if the users are going on changing stuff and then something breaks and we have to pull the plug and say back to on-prem, then this tool lets us do so to go both directions. As much as possible, we wanted to plan these kinds of contingencies up front. We didn't want to be surprised by something going wrong in production after we migrated, and then us not have a process or plan for a rollback. So all of these kinds of things we practiced ahead of time, rollouts, rollbacks, back and forth, to make sure that when we went to production, it was as boring as possible. This is Azure Portal gets a lot of flack for being can be challenging to work with. It's better now. This is one of the worst UIs I've ever seen. To select which things you want to actually synchronize up into production. So this one I go and there's this UI in which I select the tables, and then you can also select the individual columns to watch as well. So if you don't want to worry about specific columns of data, maybe there's just something that changes a lot but you don't care about, or in this case, I didn't care about the TBL log. So I just unselected that table and then it won't be migrated as part of this package. So yeah, the last thing to worry about is the schema update process. Now I was going to demo the SQL data sync, but it doesn't work in the region I picked, which was Australia East. So whoops. So if I was going to run this, I'd have to run it against Central, and it takes forever for the data to get back. So anyway, yes. So then the last thing we had to worry about was using this tool, we were going to have ongoing updating changes to the application. So we wanted to make sure that we can handle this sort of process of okay, there's features getting added, features that, that change the schema on-prem. How do we affect those changes up into our Azure environments during this migration process? Luckily, this didn't happen very often, but we didn't want to have again, batch changes to say okay, this pull request includes schema changes, put it off to the side and wait until all this Azure migration is complete. We just didn't want to incur that risk. So the way this would work when we did this update process is when we knew that there was a synchronization that was going to happen or a schema change that was going to happen, we would pause the sync. So it would not be live and trying to go back and forth. And in the UI, it's as simple as just click pause and then it's paused. We would then deploy the schema changes to both sides, so on-prem and in Azure. Now, for us, we were using a schema migration tool to do so. I think it's called, it was Roundhouse at the time, but now it's something else now. I forget the name. Oh, Great. It's called Great as in migrate. And so you may be using EF migrations or something like that. So our deployment process would just point to both on-prem and Azure and roll out those schema changes to both locations. Once both sides now had the correct schema, I would go into that horrendous user interface, find the table and column that have been added or changed or removed, whatever, and then check the box there. That would then push that metadata out to SQL Data Sync. And it would also, and this is, you can look behind the scenes of how it works, but it's pretty if I was going to invent it myself, this is probably what I would have invented. The way SQL Data Sync actually works behind the scenes is for all of the tables and columns that you enlist in this migration process, it will create triggers, an update trigger, an insert trigger, and a delete trigger. And then it creates separate tables to keep track of all those changes. So anytime I change data or update whatever, and then like it flags it in another table, so that's when the data sync runs, it only has to look at the deltas there and say, okay, these are the changes that work. So contrast this with transactional replication, where I'm just looking at the log, right, the transaction log, and applying those up into Azure. That could be more challenging to do with this process. With SQL Data Sync, it's very easy for me, and Azure Migrate and Azure Data Factory. You can simply pause those things, make your changes, and then roll them out, and then hit enable, and you're good to go. So yeah, we would then re-enable this and then run the sync. Now, the way data sync works is there's a initial synchronization that happens. The initial synchronization uses SQL bulk copy. So that is like blazingly fast for that initial data load. I think for us, because we were on-prem in Texas, running to South Africa regions, that initial push for a 200 gig database took like 10 hours or so. So even though bulk copy is really, really fast, this is why we wanted to use online migration, because it would take at least 10 hours, if not more, to export the data, then import it or copy it somewhere else to make it faster, whatever. It would take at least a day for us to do all those things, which is why we wanted to use a live online migration process, because we just couldn't wait that long. Also, there's no, like, bulk copy does not have a, there's no like progress bar. So you just don't know, like, you don't know how long it's taking. And so you can be just like, well, we're going live in production, stop the website, and then we just wait and wait and wait and wait until it's complete. The file migration, there's like, I showed like 8 tools for doing SQL migration. For the files, there's, surprisingly, there's just not a lot of tools out there to do so. They work great, but it's just kind of silly that you go to the, when you go to the documentation for Microsoft of like, okay, we have this fancy tool and UI and editor and IDE to do this migration. For files, where we're going from on-prem file server and we're using storage accounts with file storage accounts up in Azure, so not blobs. That would be another migration process. We're using this like files up in Azure. They just say use Robocopy. But Robocopy does support like incremental online migrations as well. So with the jobs file, you can do this. So it tells you the exact command line arguments to feed into this tool to be able to do this incremental migration process. So what I'm doing is creating a jobs file, which is just taking all the arguments and sticking them into a file. And then I did the initial migration, which took, again, like 3 or 4 days, because, again, I had to cross the entire ocean. But the incremental migration process would take seconds. So I had put in a scheduled basis, ran it like every hour or so. And then right before we went live, we would run this last time to say like, okay, stop the application, do the last set of migration, and it would just take seconds. One thing we didn't realize is we had to tune the threads for performance. So the initial load, you don't want to have a lot of threads, because now that's like doing a lot of, it's more IO bound, or network bound, I should say. So if I have 20 threads up front, then I'm saturating the network and it gets actually slower. But for incremental migrations, we want to up the thread counts, because it's spidering through all the folders on both sides to see what things have been added, modified, whatever. And so it's something we did after the initial migration. We used MIR to mirror and preserve structure, so the production looked exactly the same. And then we put just a scheduled task to automate all these different things. So I was surprised, like they suggested to use this janky tool that I only use in anger, but it worked actually quite well. So we said, okay, if they recommend to use it, then why not? There are, of course, other file migration tools you can use, like, I don't know, other ones. But this one worked well for us, and they already had it documented, so he said, that's good enough. So on the actual applications themselves, so that was the kind of storage migration. On the application migration, we again wanted to make sure that we didn't stop the train of their feature delivery. So we didn't want to say, stop delivering features for 3 months while we get all this up and going, and then you can finally have new features again. We wanted to be able to support this software, like we wanted to support their application lifecycle, SDLC, from kind of both sides. So the way we did this was, initially migrated their repository from on-prem Bitbucket over to GitHub. And that was a relatively easy thing to do, right? It's just Git, you can just do like, actually GitHub supports you importing from somewhere else. Unless that somewhere else is on-prem, then it doesn't work so well. But this is as easy as like, I just add a new remote in a repository and say, git push with, all the tags and whatever, and then I'll push it up over to GitHub. And then I configure my build server to look at a different Git repository. And that was fairly straightforward for us to do. So the Git side of things is actually pretty simple. Tell the team, push up all your changes, all your branches, whatever. Although I didn't have to really do that, right? You could just add a new remote, whatever. And then we pointed their existing on-prem build agents over to GitHub. Once we had that pipeline in place, now came the time for us to then build the build and release pipelines up into Azure. So what we wound up doing is instead of modifying their existing build and deploy pipelines, we just built new ones off to the side. So we built the new build and deploy pipelines over in Azure. Azure DevOps pipelines, yes. So we used Azure DevOps pipelines to manage all of the build and deployment into Azure. And then TeamCity just continues to be the on-prem deployments, manage builds and deploys into on-prem, and never would the two like mix or meet. So we just had parallel build and deployment pipelines, which means we can preserve or even design new ones, all their existing build and release strategies. So we built and designed the build and release pipelines as like they were for on-prem. Yes, so the build and release pipelines were independent, and then application configuration was then duplicated per pipeline. So if you had a new config value that had to be added over on the left, you had to remember to then add it over on the right. And now some things were not exactly the same, so things like folder names or path names or drive names, those were going to change, but there were a lot of those. Connection strings as well, right? That's going to be different in Azure versus on-prem. So we had to do that sort of migration here. So their existing way of doing their configuration was this janky pastrami tool. Was like a homegrown way of doing XML poke into web config and all sorts of crazy business. So we didn't want to do that in Azure. So what we wound up doing is we moved all the non-secrets into config transforms, because this was ASP.NET 4.8. For the .NET 6 stuff, you'd use like the app settings.blah.json. So app settings.qa.json, .stage.json, .production.json for all their non-secret values. Their secrets were a little trickier because in their current system, their secrets were being stored inside of TeamCity and then deployed and poked into XML when they did the deployment. In Azure, right, we'd want to use Key Vault for secrets. But if we use Key Vault in Azure, how are we going to manage that on-prem? Will we change on-prem to use Key Vault for secrets? Will we have feature flags to say, if on-prem, do this thing, if not on-prem, do this other thing? So we said, we'll wait for that. We'll wait until we're actually fully inside of Azure to have a strategy for proper secret management there. So for this one, we just still used ADO like the way they were doing today, which is secrets being stored in Azure DevOps pipeline variables, clicking the little padlock for secrets, and then config transforms would then poke those values into XML. ADO pipeline supports this out of the box. It's not a big thing for us to do. We just in our app service deployments, I check the box to say, and do config transforms. You tell your config files and it will do the transforms for you. One of the things we did have to figure out was ADO pipelines have limitations in their variable names. I don't even remember anymore exactly the weird jankiness they had there. But on-prem, we could do whatever we want. It was PowerShell. In the Azure deployments, we're using those app service pipeline tasks. And so there were some limitations there we had to conform to. Not a really big deal, but we just had to go back and correct them before we went over to Azure. And if there are any changes here between these two, it was a manual job. So if I added new config values over here, I would have to then remember to go ahead and add them over there as well. Now, SignalR presented its own fun challenge. So the current app uses ASP.NET SignalR. ASP.NET SignalR does not support Azure SQL. So remember, we're in a web farm environment. So if you're in a scale out scenario with SignalR, you don't want your backplane stored in memory. You want your backplane stored somewhere persistent. So SQL or a broker or whatever, not in memory. So they were on a web farm scenario on-prem, so they'd already gone through this process of putting their backplane of SignalR into SQL, right? So it's just all there together. Azure, ASP.NET SignalR does not support Azure SQL. Why? Because there's a line of code, and I finally found this because it had this very specific exception title. So you go search in GitHub, and sure enough, when SignalR starts up, and you're using the SQL backplane provider or whatever, it will check the server properties and says, if you're Azure, throw an exception, not supported. Is it actually not supported? No, it could work. Like there's nothing special in SignalR schema and tables, right? There's nothing that magical there. But there exists an Azure service for this, right? Azure SignalR. So how do you get everyone to move to Azure SignalR? Throw an exception when they try to do anything else. So Azure SignalR, this is the other problem we ran into, is not ASP.NET SignalR, the old one. It's the new one, SignalR 2.0. These are somewhat compatible, but not exactly. So you can use Azure SignalR and ASP.NET Classic. That is a thing that is supported today, but it's like the next version. So like version 1.0 to version 2.0. So like, okay, do we migrate SignalR on-prem to 2.0 and then get ready for production? Or is it easy enough for us to be able to manage it too? So we wind up just doing a feature flag to toggle between these two things. What it meant was today, the hub is hosted inside of our on-prem application. When we move up to Azure, we're no longer having to host the hub. The hub is Azure SignalR. So we actually just like wind up removing things. And there were slight API changes from 1.0 to 2.0 for the clients. And so that was just a feature flag to say, if on-prem, do X, otherwise in Azure, do Y. Wasn't that big of a deal. And then we wound up using some shims to swap out between the hubs and clients. So there's some code in there to say, like, I kind of abstracting the API of SignalR and then used a feature toggle, something like this, to say, if I'm over here, do this. If I'm over there, do that. Okay, so the networking side. So remember before there was like stuff, more stuff, and even more stuff? But now it's just gonna be Azure stuff that talks to more Azure stuff, and then even more Azure stuff, and then finally our Azure junk. Again, this is like private links and VNets, and those are the only two things I can think of. But there are all these kind of other Azure networking things to make this all work properly with security, blah, blah, blah. And so there was, again, smart people that knew all this worked. And I just said, like, I want my app service. And there it was, connected to everything, hopefully. To actually deploy this out, the team decided to use Terraform. One of the nice things about sort of a greenfield Azure deployments is that I can actually use these infrastructure as code tools. Unfortunately, these tools don't really work great for existing cloud infrastructure. Like you can point Terraform at an existing kind of deployment and we'll download like the jankiest looking Terraform files locally. So for this one, they're like, okay, this is all new, net new Azure resources. So we'll use Terraform to be able to put this out. So all these kinds of new technologies, we wanted to make sure that they would work for us. So we wound up prototyping all these different things. So all these potential technologies like SQL Data Sync, the Robocopy stuff, I created dummy apps with like dummy data and whatnot to make sure that these things could actually work before we got too far down the line of choosing resources and whatnot. So all the technologies are prototype and demoed. All the decisions were logged into a ADR. So if you get one thing out of this talk, do ADRs, because they're fantastic to have a record of decisions. Instead of just like, why did we pick Azure SignalR? Oh, right, we were forced to because of that exception. And then we use the sandbox environment and subscription as a playground to try all these different sort of tools out. So what did this look like in terms of a rollout? So about 3 weeks before a single environment was ready, the Azure environment needed to be complete. Then about 2 weeks before go live, we had to have the release pipeline finish, the data sync set up and file sync set up and kicked off. Then 1 week before go live, we would do our data validation, environment validation, and configuration validation, which then finally led into go live. So how did this actually work? So this was our process. We had both environments up and running and validated. Now we needed to do a swap from one to the other. So we would enable a maintenance mode on-prem. We still had to take the application down, but luckily it was like much less time than we originally would need to. So, this is like do the app offline thing with IS and put it offline. Also put it offline in Azure as well so that we can validate it first when we get over there. We would disable Hangfire and disable any kind of background running things to make sure those weren't also doing any kind of new transactions. We'd run our syncs the last time. So running SQL data sync and file sync one last time to get all those changes since the last time it run. So this would, because it was just those tiny little deltas, this would just take seconds to run. We had flip DNS. So over here, this is Cloudflare. We had flipped the Cloudflare DNS entries from on-prem over to Azure. Then finally, turn everything back on again over on the Azure side. So enable Hangfire, enable the applications, disable the maintenance mode. In our case, maintenance mode, we also changed over to use Cloudflare in this case. So we disabled maintenance mode in Cloudflare. Smoke test and monitor and make sure everything looks good. And then finally, pop the cork, pop the champagne, because it all worked. So we also had a kind of an incremental rollout of our different environments. So we didn't do all of one environment before we moved on to the next one. We would have a rolling set of changes to say we're going to start the rollout of one environment while the other one environment is actually completing to cut down on the amount of time for the overall completion. And then once QA was done, we would do stage and do a very fast follow to production because we had that issue where stage gated production. And so if there's weeks between stage and production, that was also weeks between when they can roll out. So just a few lessons learned here. Prototype those technologies before choosing which one works best for you. So instead of going far down the path of a migration tooling choice and realizing it doesn't work, to make a very simple set of prototypes to make sure that your choices will work in the environments that they're actually going to be running in. Don't let the perfect be the enemy of good. This is kind of a universal recommendation. There were a lot of cases where wouldn't it be cool if you used Azure Redis for caching as opposed to SQL as caching. But we just didn't want to add too many new technologies to the mix. And this is again, to resist sort of quote, fixing the architecture. We wanted to land in Azure first and then innovate once we got there, not have a bunch of things that were changing once we were going from on-prem up into Azure. Be very careful with infrastructure changes during rollout. So one of the things that got introduced between environment validation and go live is the infrastructure team decided to turn on the web application firewall, which blocked everything. So we're like, gosh, I could have sworn this application worked. What the hell happened? And it turns out they had turned on a WAF, which broke almost every request in the system. And so maybe don't do that. Maybe don't change things right before you're gonna go live, kind of settle things down a bit. And if you've done this right and you're prepared, then rollout should be boring. And it was. It was just I guess that's it. I guess we're done. And it just all worked. So thank you all very much. If you have questions, I'll be hanging out afterwards because we're right at time. Otherwise, enjoy the rest of the conference and thanks for having me.